All right, welcome back. It's time to get back into learning some math. In chapter 1.4, we learned how to take 2 points and create the equation for a line. Here in chapter 3.4, what we're going to do is take 3 points and use that to create the equation for a quadratic. Now to do that, we start out with a classic function that we've already seen for a quadratic, which is f of x is equal to ax squared plus bx plus c. We've already seen this once before. We know that the a determines the shape of the quadratic, right? A positive a means that it goes up, and a negative a means that it goes down. And we talked about the c value being the y-intercept, because if x is 0, that's going to give us the y-intercept. And the only thing left over if x was 0 would be the c value. So we've already know a couple of good things going in, which is great. So what we're going to do now is we're going to take 3 points, and we're going to use that to construct the equation for the quadratic. I'm looking at example 1 on page 213 here. It says a parabola passes through the points of 0, 5, 4, 13, and 2, 25. Now 0, 5 is a great point to have as a starting point because they've given us the y-intercept. Remember, the y-intercept exists when x is 0 and we have a number next to it here. And so the y-intercept is 5, which also tells us that the c value is 5. So that's terrific. You know, in the end of this problem, what we're trying to solve for is a, b, and c so that we can write an effective equation. So we'll go ahead and say right here, we don't know what a is just yet. We don't know what b is just yet, but we do know that c is 5. Because in the end, we're going to have f of x is equal to something x squared, something x, and plus 5, now that we know that c is 5. So our job right now is to figure out what is a and b in order to make this thing work. So what we're going to do is we're going to use the fact that this 4, 13 and this negative 2, 25 are actual points. And that if I put 4 in for x, the end result, the f of x, is 13. If I put in negative 2 for x, the end result is 25. So I'm going to move my f of x essentially to the right-hand side because I want my a's and b's on the left and my non-a's and b's on the right. And so we're going to use 2 equations. We're going to call this one equation 1 here. And in equation 1, we're going to have a times x squared, except the x is going to be 4. So we're going to have a times 4x squared plus b times our x of 4s again, plus our c, which we know is 5. And the end result we also know is 13 from the point because it says 4, 13. Put in 4 for x, you get 13 as an answer. We're also going to have equation number 2 here. And equation number 2 does the same thing, except we use negative 2 and 25 for that. So we're going to have a times negative 2 squared plus b times negative 2 plus our c, which we know again is 5, equal to 25. Okay, now we want to consolidate these a little bit here, so let's do it right here. So we're going to have equation number 1. We're going to have 4 squared, which is 16a. We're going to have 4 times b, that's called 4b. We're going to say equals. We're going to have the 13, which we know is on the right already, and then we're going to go ahead and take this 5 and bring it on over. And remember, though, there's a price to pay when we bring it over. It's subtracting. Some of you may also do a subtraction on both sides. Remember, that's fine too. I always do a movement versus a subtraction, but either way works. And we'll do the same thing for second equation here. So we've got negative 2 squared. That's going to be 4a. You've got negative 2 times b. That's going to be minus 2b. And over here you've got 25, and once again move the 5, it's going to be minus 5 one more time. All right, we can consolidate that a little bit better, right? Because 13 and 5 is going to make 8, and 25 and 5 makes 20. So let's go over here, and let's call this, once again, equation number 1 here, and we'll say that 16a plus 4b equals 8. And then equation number 2 here, we're going to have 4a minus 2b equals 20. That's great. You know, what's even better about this is that when I look across the first equation, I see 16 and 4 and 8, and I know they all have a factor of 4. So I know that I can reduce these things and make them smaller. And the same thing goes for number 2. I look across these and I see they have a common factor of 2. And so let's go ahead and do that. So in equation 1, let's go ahead and just divide 4 by everything. So 16 divided by 4 is 4a. 4 divided by 4 is 1b, and 8 divided by 4 is 2. In equation number 2, same thing, except we're used 2 this time. So we're going to have 4a divided by 2, which is 2a. We're going to have negative 2b divided by 2, which is minus 1b. And finally, we're going to have 20 divided by 2, which is 10. And now we've reduced them, they're going to be easier to work with. Remember, I always say smaller things are easier to work with. And because we've done that, there's now a natural elimination set up between the b's. Look at this. We've got plus b and we've got minus b. And they're both 1. One's plus, one's minus. Perfect to do an elimination. So that's what we're going to do, is we're going to do an elimination here so that we can say 4a plus 2a, that's 6a. We can say the b's eliminate, cancel themselves. And then 2 and 10 make 12. 6a equals 12 means that we can divide 6 on both sides so that a equals 2. That's awesome. Hey, we just figured out another value that we needed. We now have 2/3 of the values. We have a and we have c. We just need to find b. And the other great news about this is that once we find a, we can use that to now find the last thing to find our b. So what we do is we pick either equation, 1 or 2. And it doesn't matter which equation that you pick. I like 1 in particular because the b is already positive. So I'm going to take this a equals 2, and I'm going to substitute that into this a right here on equation number 1. So let's do that right here. So equation number 1 there, we're going to have 4 times 2 plus b equals 2. Well, 4 times 2 we know is 8 plus b equals 2. We take this 8 and we move it over here. We're going to have b equals 2 minus 8, which means that b is equal to negative 6. Hey, we just found the last one. That's awesome. And now that we know that a is 2 and b is negative 6 and c is 5, we can finally answer this question to begin with, which is to write the equation out. And the equation is 2x squared, that's our ax squared, minus 6x, that's our plus bx, and then finally plus 5, that's the c value. So we got our equation. That was the whole goal of this exercise. Took a little bit of work, a couple of one elimination and one substitution to get there, but in the end, we got what we needed to get.